This is just an introductory lesson just to introduce you to the Webex Edge Solutions. There are 3 products in the Webex Edge solution you should be familiar with: Webex Edge Audio, Webex Edge Connect, and Webex Edge Video Mesh. Now, Webex Edge Connect is completely dependent on a third-party product outside of Cisco, and so I will not be going deep into how to configure Webex Edge Connect. I will, in this lesson, only give you a brief introduction to what Webex Edge Connect and how it can be used in your, what Webex Edge Connect is and how it can be used within your environment. I will do the same for Webex Edge Audio and Webex Edge Video Mesh throughout this lesson, but then in the next 2 lessons after this, when we come back after lunch, I will go into depth on how to configure Webex Edge Audio and Webex Edge Video Mesh, and time provided, I may do some demos for you on that during that time as well. So let's go ahead and get started in this lesson. The Webex Edge solution, first thing you need to understand about it is that it is a single offering now that consists of 3 core capabilities. So Webex Edge includes Webex Edge Audio, which provides an on-net voice over IP path for participants to be able to join meetings from their existing IP phones with no change in behavior or additional training needed for your users. Webex Edge Audio supports all CUCM platform solutions, providing high-quality audio by bypassing the PSTN. It also greatly reduces PSTN costs when you do have to place a call over the PSTN by simply leveraging your own PSTN services that you have set up on-prem. The second component of Webex Edge solution is Webex Edge Connect, which is a dedicated, managed, QoS-enabled IP link from your on-premise environment to Cisco Webex Cloud through direct peering, which leads to faster Cisco Webex meetings powered by the Cisco network backbone. The direct connection provides consistent network performance, plus it adds additional security to your environment as well. The third Webex Edge solution component is the Webex Edge Video Mesh, which allows users to enjoy industry-leading media experiences by providing a local instance of the media processing for lower latency and overall internet bandwidth savings. The Video Mesh node is software that's installed locally on the customer premise environment. It facilitates the routing of Webex meetings to the local on-net Video Mesh node in order to join the participants together in the meeting. This service chooses the most efficient way to use the available resources, creating a better overall experience for all of the users. So let's look at each one of these individually, starting with the Webex Edge Audio solution. Now, before we get into Webex Edge Audio, we have to examine what problem Webex Edge Audio resolved. So prior to using Webex Edge Audio, this slide illustrates how Webex Audio was configured and operated. Traditionally, companies had 2 options for participants who wanted to call into a Webex meeting from an IP phone, and both of them were costly. And it doesn't make sense because you think an IP phone should be able to call into an IP cloud-based platform over IP, but that was not true. The first option was those IP phone users had to use costly audio-only circuits that allowed the user to dial in, or you could do a callback from Webex to the user over that same circuit. But again, it was costly, very expensive. It was all built into Webex, and it was just, it was expensive. There's no other word for it, right? The second option was to use the public PSTN, which also incurred costly charges to the company. So either way you go, you're incurring charges because you're going across the PSTN network. Now, for video content, as you know with Webex, you can connect video also. Video didn't use the PSTN. Video content always used an IP connection. And this didn't matter if you were streaming video, your actual live video, or you were sharing content over video. Either way, it was an IP connection. So Cisco figured, yeah, we can allow an audio connection over IP as well, but only if you're using the audio resources of your computer through which you're sharing video and content, which meant you're using your computer's microphone and speakers to do the IP connection, not your IP phone. And so the quality of that audio was never as good. And it could often be very disruptive during the meetings, especially if you're on a Mac computer. And I'm on a Mac computer. There's a reason, I don't know if you noticed yesterday when I shared my video, but there's a reason why I'm wearing a headset. Because on Mac computers, for whatever reason, and they've never fixed this, I just bought a brand new Mac back in December, and it's the same issue on this Mac as it's been on every other Mac I've used over the years. They put the microphone in the Mac so close to the speakers that it always creates feedback. And I've noticed a lot of Windows-based PCs have started doing that too. And I don't understand why, from a manufacturer perspective, why they do that. It would make so much more sense to put it somewhere else, but they locate the microphone so close to the speakers that it creates feedback. And so it's things like this that create a very disruptive environment during meetings when you're using your computer for audio. And there are ways to overcome it, but again, you have to add things to your environment in order to overcome these distractions. And so it wasn't the best solution, right? It wasn't ideal to do audio, to expect people to do audio over their computer, right? People want to use their IP phone. It's what they have it for. Why can't they use it to call in a meeting over IP? So Cisco said, you're absolutely right. IP phones should be able to call over IP into our IP-based Webex solution. That just makes sense. And that's why they created the Webex Edge Audio solution. So Cisco developed and delivered this new Webex Edge Audio design in order to allow IP phones to call into Webex meetings over IP, which lowers the overall audio costs incurred by companies that use the Webex meeting solution. And in addition to lowering the cost, companies have an increase in audio quality during these hosted meetings because they're allowed to use those IP phones. We'll understand why here. Can't remember if it's this slide or the next slide, but coming up here. So Webex Edge Audio can be leveraged by companies of any size that use a Cisco Unified Communications Manager, and that can be used without restriction. There's no limitation to who's allowed to use it. Webex Edge Audio allows customers to use voice over IP or their own PSTN service based on something called intelligent audio routing, which is built into the solution. And intelligent audio routing connects the CUCM to Webex Cloud and allows them collectively to make a decision how best the call should be routed, whether it should be over PSTN or IP. And it gives a precedence to IP. So it's going to try to connect over IP first. If that fails, then it uses the PSTN only as a fallback solution, right? It creates an end-to-end voice over IP path for CUCM registered devices, whether users are dialing into Webex or they're requesting the callback option from Webex to their phone. Not only from their PC, but also from any Cisco registered phone, completely transparent without any change in behavior to the user. So the same way users have dialed into these Webex meetings historically is the same way they dial in now using the Webex Edge Audio solution. And then this in turn provides great cost savings for the company itself, as it eliminates those PSTN charges created by the employees. And at the same time, it provides users with all the benefits of the high-quality wideband audio codecs that's offered through not only Webex, but through your on-prem CUCM solution. So for other users with non-CUCM registered phones or mobile devices, the company's own PSTN service can still be used. Cisco has democratized audio savings while also improving the audio quality for calls on CUCM registered devices. Webex Edge Audio can be used as an alternative to cloud connected audio, CCA, where most of the PSTN cost savings can also be achieved through CCA SP for service providers. Most CCA partners provide options to keep on-net calls out of the PSTN path by providing SIP trunk type integration. So Cisco is providing a choice here for customers to either geographically or on a case-by-case basis, whatever suits the customer best. So the real cost savings and value proposition, though, in this solution is around the ability to leverage your existing Cisco UC investment in order to deliver premium callback services for free with Webex Edge Audio. Then IT can choose how they want to leverage Edge Audio, whether it be globally or maybe just in select countries. Now, adding Edge Audio into your solution can be added a couple different ways. It is included in the Cisco Collaboration Flex Plan 2.0, which just came available in September 2019. It's also available for customers that order the ASPK or AWBX license models, but there is an extra cost incurred with those. So if you're using Flex Plan already, Flex Plan 2.0, or you're upgrading your license to Flex Plan 2.0, Webex Edge Audio is included in that automatically. Webex Edge Audio can be used with any of the Webex platforms we talked about yesterday, so you can use it with Webex Meetings, Webex Event Center, or Webex Training Center. The products needed in order to deploy the Webex Edge Audio solution include the CUCM, Expressway Core, Expressway Edge, and obviously you have to have a subscription to Webex. Note on this slide, though, that specific minimum versions and licensing must be met in order to successfully deploy the solution. RMS licenses on the Expressway are not a required license because calls are just going out to Webex. And RMS licenses have never been required to be able to call into Webex. However, you do have to have a Webex subscription with AFlex, AWBX, or ASPK SKUs, along with the Webex Edge Audio package. Also notice that the CUCM must be configured with specific audio codecs for Edge Audio. When we talk about how to set this up later, we'll talk a little bit more about how to set that up as well. It's an easy thing. So let's talk about Webex Edge Connect now. And again, just like with Webex Edge Audio, we want to establish what the need is for Webex Edge Connect before we talk about what it is and how it operates. So in a basic deployment, all media communication to Webex Cloud has to traverse through the public internet. Not sure if you are aware of that or not, but that's how we get there, right? And this can create issues because there's no QoS across the public internet, so all communication is best effort. There's also no guarantee of bandwidth, therefore businesses could be experiencing poor media quality during these meetings just because of the nature of going across the public internet space. Enters Webex Edge Connect. Webex Edge Connect is an edge service leveraged through a company called Equinix. Again, third-party company providing this service. They establish an Equinix Cloud Exchange that sits between the customer premise and Webex in the cloud. This service provides a more secure private connection to the cloud with guaranteed QoS and bandwidth, plus a bunch of extra other security policies they put in place as well. So think of Webex Edge Connect as an opportunity for you to experience, to save money and provide a better user experience during your meetings as you join them. When the Equinix Cloud Exchange is leveraged, the signaling still flows along the direct path to the Webex Cloud through the public internet. However, the media flows along a different path through the Equinix Cloud Exchange service. And this is true for any device connecting to Webex from behind the corporate network, regardless what device they are connecting from or whether or not they're using the Video Mesh node, which we'll talk about in a little bit. I mentioned PSTN fallback a little bit. Webex Edge Audio can be set up for PSTN fallback in the event there are routing or connectivity issues. This feature is enabled automatically for Webex Edge Audio customers, but there is an option to disable it if you don't want to use it, right? And so PSTN fallback works. The kind of significance of this slide is PSTN fallback works whether Edge Connect is deployed using Equinix or not. Used to be when Webex Edge Connect first came out, you could not use these two services together. You had to either disable PSTN fallback or not use Webex Edge Connect. In this case now, though, Cisco has updated this, and these two features do work together. We also talked a little bit about CCA, Cloud Connected Audio, which is an audio conferencing service that is delivered from Cisco Webex platform, and it natively integrates into your Webex meeting service. It uses IP connections in a Cisco data center as an alternative to or in addition to the public switch telephony. So it's just another way to do that kind of cheaper routing thing. CCA delivers one of the best and most consistent user experiences that's flexible and cost effective, also while using your on-premise IP telephony investment, and it can be delivered as a service from a service provider or as a direct enterprise architecture. So there's different ways to purchase it. You don't have to go through a service provider, but you can. You have options here, right? A lot of people wanted CCA to be able, customers who had CCA wanted to be able to use that in some scenarios, but in other ones be able to use Webex Edge Connect. So Cisco built it now so that CCA can be used in conjunction with Webex Edge Connect through the Equinix Cloud Exchange. These mixed environments enable customers to keep their CCNA SIP trunks where they're deployed today, while expanding to new locations using Edge Connect to provide that direct peering for Webex media traffic using VoIP, video, and content sharing. Cloud Connect Audio, or CCA, can also be used in deployments that allow PSTN fallback. Again, that's a new feature. PSTN fallback was always an independent feature. Now it can be used in connection with CCA. It can be PSTN fallback can be used in connection with the Equinix Cloud Exchange, and you can use all three together or in any combination of the three that best suits your environment deployment. So, with all of this set up, where can customers expect audio costs to occur? Assuming that the customer or user has set up CCA, SP, PSTN for off-net calling, or you have PSTN gateways or session border controllers set up in your environment, then audio costs can occur in one of two places. If you're routing off-net via CUCM voice gateway, customers will have local PSTN charges from their PSTN gateway. So that's assuming you have someone on a mobile phone or you choose to go be routed across the gateway services, or maybe your expressways are down and so calls have to be rerouted. Whatever it is, if you're going across the PSTN, that's where you're going to incur charges. Second, if you use the callback option via Webex Edge Audio and it has to fall back to PSTN because maybe you've exceeded bandwidth restrictions, or again, there's network services down or DNS is down or something else, then in that instance, because you're falling back to PSTN, you will incur PSTN charges then as well. So the purpose of these solutions is not to eliminate PSTN costs, but simply to minimize the PSTN costs and therefore increase the savings you can see by allowing more calls to go over IP. Now, this subject goes way deeper than what I'm covering here. I did a week-long course just on Video Mesh. It was a 5-day custom class I wrote. It was all things Video Mesh. It took 5 full days to go through it all. Very intensive stuff. I'm going to give it to you all in a couple hours. So obviously I'm not going to go as deep or in depth on Video Mesh, but hopefully over this lesson and the Video Mesh lesson, the rest of this lesson and the Video Mesh lesson, it is going to give you enough to understand it a little bit better if you don't already. So Video Mesh was formerly known as Hybrid Media Service. So it's not a new solution. It's a solution that's actually been around for a while. Hybrid Media Service was something they added into Spark back in 2015, I believe it was. So it's been around for a while, a good 5 years. This isn't a new solution. It's just newly part of the defined Webex Edge Solutions, right? And when Cisco was getting ready to make the switch from Spark to Webex, they did retitle the hybrid media service as Video Mesh. But it is the same thing. So what is it? It's a conferencing solution that delivers a better video experience by allowing the Webex video communication to be delivered on premise, meaning you don't have to connect to Webex in the cloud to host a Webex meeting, which is kind of cool. Now, there's several issues that the Video Mesh solution resolved. Prior to Video Mesh, when meetings were hosted through Webex, there was a lot of communication streams traversing out to the cloud. And this could cause network congestion at the corporate network edge, and a lot of bandwidth was being consumed as well. Cisco's solution to these issues was to allow a meeting server that interworks with Webex meetings in the cloud to be installed on premise so that traffic into and out of the corporate network can be controlled more granularly. And the Video Mesh node is that conferencing product. Webex Edge Video Mesh enables industry-leading media experiences by providing a local instance of the media processing through the Video Mesh node software for a lower latency and overall internet bandwidth savings. So Webex Edge Video Mesh keeps local media on premise and then joins local participants together in a meeting at the edge. So in other words, if you have participants and all the participants are within your corporate network, then they're just going to, they call into a scheduled Webex meeting, they're going to call into the Video Mesh node. And then the media stops there. It never goes out into the cloud. It stays on the Video Mesh node. Or like in the graphic you see here, maybe I have 2 different locations, right? I have location A on the left, location B on the right, and I have a Video Mesh node set up at each location. Then local participants at each of these locations can connect to their local Video Mesh node, and then I just have a single signal going from this Video Mesh node out to the cloud, going from this Video Mesh node out to the cloud, and it joins the 2 meetings together into one. Video Mesh optimizes how participants are connected to meetings and how they're connected together, enabling lower latency, bandwidth savings, and creating better meeting experiences for users. So by allowing local participants to connect to this local Video Mesh node, I'm not going across the network. So I'm going to have lower latency, lower delay, And then if I do have to connect out to the network, I'm sending a single compressed video signal or video media, or I guess, out to the web. And so I'm using less bandwidth for that connection. Instead of sending 5 or 6 video streams out to the web individually, I'm only sending one video stream out, and therefore I'm using less bandwidth as well. So now the quality of my meeting is going to go up exponentially. You can use, Video Mesh also helps with video quality because you can optimize it with the use of Webex Edge Connect. And there's the ability to cascade meetings out to the cloud, as I mentioned before, which helps facilitate overflow capacity when additional users join a meeting beyond what a video mesh node can support. Now, you can cluster video mesh nodes as well, but let's say, for example, I have a single video mesh node in this corporate network, and I can host, I don't know, hypothetically, let's say I can host 12 connections to it, right? When a 13th participant calls into that video mesh node, it doesn't have the capacity to host that additional participant calling in. And so what will happen is that participant can be redirected out to the cloud, and then a cascade link is established between the cloud and that on-premise node so that everybody can see everybody else, hear everybody else, and it's as if they're all connected to the same server directly, even though in fact they are not. So when a video mesh node or cluster is set up within a corporate network, there's only certain devices that are even allowed to connect to those nodes, and they can only connect at certain times, as I mentioned aforementioned before. So, for example, endpoints registered to the Webex Control Hub and Webex Teams clients, not Webex Meeting clients, Webex Teams clients that are within or near that corporate network can call through the video mesh node. It doesn't mean they will, it just means that they can. So they're going to consume some of those user license on the video mesh node. Also, endpoints that are registered on premise to a CUCM will call into the video mesh node, provided resources are available. Now, any of these types of devices, the attempt to call into a video mesh node when it's out of resources will be redirected out to the cloud, but a cascade link will automatically be created back to the video mesh node so that they are still part of the same meeting and can see and hear the other participants connected to the video mesh node. This cascade link does not impact the video layout nor the video quality. So that should all be the same, right? Now, who else cannot connect to the video mesh node? Because there are some devices that will never connect to the video mesh node, but always call directly out to the cloud. So if you have participants using Cisco WebEx Meeting app, or Skype for Business app users, or guest endpoints outside the corporate network, they will always use the cloud. They'll never use the video mesh node. Even if they're sitting on top of the server, they will not connect to it. And there's no way to force that, right? It's just by design, they will not connect to the video mesh node. Webex Teams app users or endpoints that are registered to the Webex Control Hub that are located outside the corporate network may call into the cloud directly anyways, even with resources being available on the video mesh node. It really depends on a round trip time. Because what happens with these devices is when the endpoint registers to the Webex Control Hub, or when a Jabber Teams user first signs into their client, it sends out a round trip time to Webex. And it does a test. Webex will say, hey, first the client says, hey, are there any video mesh nodes near me? And the Webex in the cloud says, yep, here's the video mesh nodes that I have registered to your organization. Then they do a round trip time test using stun to each of the video mesh nodes and to any cloud Webex data center that they have reachability to, and then it takes that data, those round trip times, and prioritizes them by lowest to highest and sends this information back out to Webex. And it's basically telling Webex, hey, here's the list of servers I want to connect to. There's my first choice, second choice, third choice by priority of that round trip time. If the video mesh node is less than 150 milliseconds and is the closest node to that client, the client will connect to that video mesh node, assuming there's resources available. But if I have an endpoint or client outside of the organization where that round trip time exceeds 150 milliseconds and there's somewhere in the cloud that's closer by proximity due to that round trip time, then this client will connect automatically to the cloud, even if there's resources available on the video mesh node. So it's all dependent on that round trip time. But for on-prem endpoints, that has to do with routing behavior setup in the CUCM. So they will always try to connect to the video mesh node first, and then by second priority, if no resources are available, then they'll connect out to the cloud. All right. So let's be more specific here and examine specifically what devices can and cannot connect to the video mesh node, beginning with devices that can connect to the video mesh node. Now remember, we're saying they can, not necessarily that they will. They have that capacity to be able to connect to the video mesh node, because there are some devices that do not have that capacity within them no matter what, right? So any Cisco Webex registered device can use the video mesh node. Now there's something very specific I have to clarify here. That's any telepresence device. So SX endpoints, MX, DX, room series endpoints, Webex endpoints, the Webex board, those types of devices that are registered to the Webex Control Hub, they can use the video mesh node. This does not include UC video phones. We'll talk about that more on the next slide. Any Webex team app user, whether they're on a desktop or mobile, that includes Windows PC, Mac computers, mobile phones, tablets, anything like that, where the Webex Teams application is installed. We are not talking about devices that are registered, the users that are logged in using their, like a web browser, like can't open up Chrome and sign into your Webex Teams application that way and then use the video mesh node. That won't work. You have to actually download the Webex Teams application on that device, and as long as you've downloaded the application, then the video mesh node can be used, right? CUCM registered devices. This includes any device registered to the CUCM. So not just your telepresence endpoints, SX, MX, DX, Webex endpoints, but also your UC phones, Jabber soft clients, Jabber VDI, anything that's registered to the CUCM can use the video mesh node. Now, when we're talking about Jabber, or not Jabber, but UC phones specifically, I like to specify any UC phone running enterprise software, because the software running on the phone determines where that phone is allowed to register to. If the phone is running enterprise software, then it's registered to the CUCM. Therefore, it's allowed to use the video mesh node. If the phone, the UC phone, is running MPP software, then it has to register the Webex Control Hub and cannot use the video mesh node. Very specific there, right? So CUCM registered devices, including UC phones, as long as they're running enterprise software. Cisco VCS Expressway registered devices. whether it be a VCS or Expressway Core Edge, doesn't matter as long as they're registered to one of those devices and it's set up to use the video mesh node, then they can call in. And that's true whether they're registered using SIP or H323. Now, if you probably don't use H323, but if you are still using it, there is a caveat there. The video mesh node is only set up to use SIP. Therefore, you will have to use the inner working function of your Expressway to convert the H323 signaling over to SIP before it's sent out to the video mesh node. But the calls will still work, right? Can use video mesh node. Cisco Webex VDI clients can use the video mesh node. And then last but not least, and this one can be a little confusing, and I'll try to clarify it on the next slide, but if I have a Webex registered telepresence endpoints, that's your SX, MX, DX, Room Series, or Webex board, and I request the callback feature from Webex to connect my audio, that endpoint can still use the video mesh node. Notice this is specific to endpoints registered to the Webex Control Hub. The callback feature to on-prem registered endpoints will not work, and you'll see that again in the next slide. So let's go ahead and take a look then at what endpoints cannot use the video mesh node. And this includes any Webex Teams browser clients. So we talked about Webex Teams application users can connect to video mesh node, but if you go into a browser, does not matter if that is Safari, Firefox, Chrome, Internet Explorer, what's the new one? Edge, Microsoft Edge, any of those, you go into the web login through that browser for Teams. You go to teams.webex.com, sign in with your account. You can sign in, you can connect to meetings, but you cannot use the video mesh node. And this is one example that illustrates that there is not full feature parity between the Webex Teams application and Webex Teams web browser client, right? So best practice, always use the downloadable application. Try to avoid using the web client when possible. Any Webex calling registered phone, we're talking about UC phones with registered for the BroadSoft backbone, which is actually why it won't work. When you're registering the Webex Control Hub, you're not actually registering directly to the Webex Control Hub like you are with telepresence endpoints. It's a different engine that's powering that registration and calling feature, and that engine is powered by BroadSoft. That engine has not been set up to work in conjunction with the video mesh node. Therefore, if you're registered to Webex with one of these UC phones, this would include the 6800, 7800, 8800 series phones, right? Then you cannot use the video mesh node. If you're using the Webex meeting application, this application is designed to always call into the cloud, never call into the video mesh node. So you cannot use these applications to call into the video mesh node. And then finally, if you're requesting the callback feature from an endpoint that's registered on-prem to either a CUCM or an Expressway, then you cannot use the video mesh node, because the only way those endpoints can reach the video mesh node anyways is through routing behavior that's configured in that call control device. So when the endpoint initiates the call out, it tells the call control device, here's where I want to go, and the call control device is set up to reroute it to the video mesh node. But when you're doing the callback feature, you're not going to route Webex in the cloud back to the video mesh node, because that wouldn't include the endpoint. The Webex in the cloud, when it calls back, is calling the endpoint, and it's the cloud calling the endpoint, not the video mesh node. Therefore, when you do the callback feature for an endpoint registered on-prem, it will not use the video mesh node. There's no way to create that kind of routing behavior. All right. So now that we've established that video mesh nodes can be installed on premise, it's important to understand where these servers can be installed. And there's two locations you can put them. You can install the video mesh nodes either in a single instance or in a cluster, because you can cluster them together. And they can be installed on the internal network or in the DMZ, but you cannot install them in both. If you're thinking, let's create a firewall traversal solution and just have the internal video mesh nodes point to the DMZ video mesh nodes, which point out to Webex in the cloud, forget it, it's not going to work. There's no way to do that. And you'll understand that here in just a moment. So let's look at the internal one first. When the video mesh node is installed internally, devices easily connect to the video mesh node, which in turn connects out to Webex in the cloud when necessary. No need to set up Expressway Core and Edge, because the video mesh node has the ability using HTTP to send the media directly out to Webex in the cloud. If all the participants connecting to the meeting are internal, then there's a real advantage to this one because the media is also kept internal to the company through the video mesh node, and then Webex in the cloud is never used. Now understand, the video mesh nodes do still send a signaling message to the cloud. They're just not sending the media out to the cloud. We're keeping the media, which is really the bandwidth consuming component of these meetings, internal on that video mesh node. Now, if participants external to your organization connect to a meeting through the cloud, then at that moment, the video mesh node will establish a single connection out to the cloud with a composite of all the participants in the meeting internally connected to the video mesh node, and that way those participants in the cloud are able to see and hear participants that are internal and vice versa. Internal participants will be able to see and hear anybody externally connected to the cloud. However, that single connection, because it's a composite image of all the audio and video, consumes less bandwidth across the network, and therefore the quality of the meeting improves exponentially. Right? So that's the real advantage of putting a video mesh node into a solution where you have on-prem participants connecting. Now, when the video mesh node is located in the DMZ, the operations are basically the same. However, the media is no longer kept internal. The media is external to the company because it's in that DMZ. Participants, even if all the participants in the meeting are internal to the network, the media still has to go through that first firewall. And therefore, you have to set up firewall policies and so forth to allow that media to go in and out of that firewall. So it's going to be a little bit more complex to set up. Now, it's also going to be more secure, and that's kind of the point of this. Why would I put it in the DMZ if it's harder? Because it's more secure. Because that way, when participants outside my organization connect to a meeting and that media is sent into the video mesh node, it keeps their connection outside of my internal network. It's a security measure. That's it. That's why you would do it. Now, does that mean that if I have my video mesh node internal, like I'm showing you here, that that's not secure? Of course it is. Absolutely. This is a very secure solution, right? It's just there's some companies that they want it more secure than this. They don't want that media from outside coming into their network. And therefore, Cisco offers an alternative to those types of companies who want to see a little bit extra security in there by setting up the video mesh node within the DMZ. Just remember, though, with added security comes added complexity. So security policy does not allow the Cisco Webex network ports to be opened outbound for media directly to the internet from the internal network. Therefore, a DMZ must be set up for this type of deployment to work. If you haven't set up a DMZ yet, you have to establish one before you can deploy this type of solution. The video mesh node cannot sit directly on the public internet side. It has to be in a DMZ. So just keep that in mind. Now, you might be saying, well, I want the internal participants to connect to an internal video mesh node. But I like the idea of keeping external participants outside of the internal network, so why don't I put a video mesh node in the DMZ and stick another video mesh node internal? But this solution right here that I just described, this is not an option. It is not a firewall traversal solution. That's what the expressway core and edge is for. That's your firewall traversal solution, not these video mesh nodes. It's not the intended purpose of these servers either. Because these servers have been designed to communicate directly with the cloud. They will never communicate with one another. Therefore, you couldn't set this scenario up anyways because it goes outside of the designed purpose behind these video mesh nodes. Okay? Now, in order for on-premise endpoints to be able to have their calls routed to the video mesh node, you must create a SIP trunk from the CUCM to the video mesh node with appropriate SIP route patterns configured. Notice in this slide that the lock icon is unlocked, and that's because historically, when you were setting up a SIP trunk for video mesh specifically, the SIP trunk security profile had to be an unsecure TCP communication. You couldn't do secure. That's not true anymore. As of last summer sometime, or maybe in the spring, I can't remember when they changed it, you can now do a secure SIP trunk security profile between the CUCM and the video mesh node using TLS port 5061. Now remember though, with added security comes added complexity, and therefore there's a lot you have to set up here. You have to sign certificates on the CUCM. You have to build and sign certificates on the video mesh node. Then you have to build a trust from the video mesh node. The video mesh node has to trust the CUCM certificates. The CUCM has to trust the video mesh node certificates. And then once all of that is set up, you have to go into the Webex Control Hub out here in the cloud, and you have to set up all of the security components in there to allow this secure connection to go through out to your endpoints. Otherwise, the endpoints by default are set up to use just regular TCP. They won't even try to do a secure connection. And so in order to prompt those endpoints to do a secure connection, you have to change some settings in the cloud as well. Very complex, a lot of steps involved with setting up a secure connection. Much easier just to set up the old standard non-secure. And again, if I use non-secure SIP trunk security profile, does that mean it's not secure? No, not at all. The video mesh node, when it communicates with Webex in the cloud, it's using HTTPS. It's putting its own security measures in there to encrypt this data. You couldn't get that data hacked, but some people want that data encrypted end to end, from the endpoint all the way to the endpoint on the other side. And therefore, that's why they now allow you to do secure SIP trunk security profile on the CUCM. All right. So let's put all these pieces together now. Once the video mesh nodes have been installed and set up and the SIP trunks have been established with all the additional configuration elements needed, the dial-in flow to the video mesh node will progress as follows. When a client or endpoint initiates a call to a Webex meeting, the dialed alias is sent to the CUCM. Obviously, it's the way behavior always works, right? The CUCM will then match the alias to a SIP route pattern, which points to a route list that points to a route group that contains a list of SIP trunks which are searched by priority of the list from top down. At least if you're configuring it the way it's recommended, that's the way it will be searched. The first SIP trunk in the list will establish a communication with the Video Mesh node. The Video Mesh node will in turn send a meeting request out to Webex in the cloud, and a meeting is then created on the Video Mesh node. So as I said before, there's always signaling that's sent between the Video Mesh node and the cloud no matter what. But media, once that call is set up and the cloud says, yep, you're allowed to have a meeting, the media is direct between the endpoint and the Video Mesh node. And that's the key. The media, in this instance, does not go out to the cloud. Now, what happens when an endpoint tries to connect to a meeting, but there's no resources available on the Video Mesh node, right? Because it's at max capacity, a bunch of users have called in or having meetings, someone else tries to join a meeting, what happens then? Well, the Video Mesh node will still send the signaling out to the cloud, hey, someone's trying to establish a meeting, but the response that comes back from the cloud is going to be a 488 error code, which essentially says, sorry, you don't have the resources for it, you need to find another way to connect, right? This is not an acceptable route. You need to look for an alternative route. Now, assuming you have set up an alternative route, then the CUCM will look into that route group, find that other SIP trunk that points to the Expressway core and Expressway edge pair, and then the call signaling is sent out through your expressways to the cloud, Webex in the cloud, to try to establish a connection. Assuming there's no issues in setting it up in that media, direction path, now the media of that call will go from the endpoint through your Expressway core and edge out across the internet and connect to that media node in the cloud. Then a cascade link will be set up from that server back to the Video Mesh node if other participants you're trying to connect to are connected to the Video Mesh node. But for this participant, and that's all I'm trying to show you here, the media actually goes out to the cloud. All right. So that is Video Mesh node, and that concludes the introductory lesson, lesson 6 on Webex Edge products.